Hello? Hello? Okay. I think the webcam audio might be working. Yeah, okay. So, hopefully the audio is working now. Um, yeah, we'll start in here in just a sec. Okay. Okay, hello everyone. I apologize for that little snafu. For some reason, the webcam I'm speaking to right now has this kink where it'll like stop working unless I unplug it and plug it back in, and sometimes the audio doesn't come through either, and that's the same fix. I really should just be using like a clip-on microphone for this, like I do for normal videos, but oh well. Um, In any case, sorry for starting a little late. I scheduled this assuming that I'd have enough time to run over to my mailbox and pick up the package we're going to open. That took longer than expected. First, when I got there, there were some people in front of me that were waiting on notary services, so that took a while. And then the mailbox is at this place that's sort of inside of a much larger store, and every once in a while packages get delivered to the store's loading dock, not to the mailbox place, and then the people from the mailbox place have to run to the other side of the store, pick up the package, carry them all the way across. It's really a pain. Usually FedEx has been known to do this. This time it was actually UPS, which kind of surprised me, but that took more time. Then on the way out, I was using one of the store's shopping carts, and one of the wheels locked up right as I left the entrance of the store. That's actually happened to me before. You know, you're pushing this big box in this cart, and all of a sudden it just stops dead. Another annoyance. But in any case, I'm here. I got back. I have the package. And now, yeah. So, when we left off at the end of yesterday's live stream, which ended abruptly, unfortunately, because my internet connection just conked out at the wrong moment, and I wasn't quite sure how to restart it, but I was checking out one of the circuit board panels, and there were a couple of problems that I had spotted. I don't know if I fixed them live, but one of them I've since fixed. The other I'll just have to deal with later. But, you know, there wasn't that much left to check out of that. This morning I went through several more panels, didn't record any video of that, and I'm probably not going to record video of most of that because it's just kind of repetitive and boring, and I'd rather get through it quickly. But today we're going to move on to something a little different. Today has arrived the last box of parts that I need before I can actually start building devices. And that is the commercially 3D printed enclosures for the Printilizer densitometer. So doing commercial 3D printing for this has been quite an adventure. The design doesn't come out quite as good if I print it on my normal home style 3D printer. There's all these kinks with support materials and orientation. I can produce a halfway decent result, but not in any sort of volume. Like, it's okay for a one-off if I'm careful, but it's not quite what I would actually want to sell. So I've been going back and forth between a couple of different 3D printing technologies. In fact, a lot of older prototypes used might look blue like this. You may see some old pictures like this. So commercial 3D printers don't always use the same process as your home 3D printer. Home 3D printers have this nozzle that squirts out a layer of material, moves up, squirts out a layer of material, moves up, squirts out a layer of material, moves up. It takes forever, and it can't squirt over thin air, so there might need to be some support material that adds extra hassle. So I was evaluating a couple of different 3D printer technologies for this project. One that I was almost going to use before I changed my mind is what the blue enclosure that you may have seen earlier product photos use, called SLS, which stands for Selective Laser Sintering. It feels very nice, comes in a variety of colors, but has one fundamental problem. It's translucent, especially to infrared. So any part of the densitometer that light passes through can't be made out of this material. So yeah, here's an example of a complete top. So my approach was actually to 3D print like the sensor cone and this ring here on my home 3D printer and glue that in. And it kind of looks pretty, but it's a lot more work to make and put together. The other commercial 3D printing technology is one you might have heard of, I think because Ravenni Labs made a big deal when they were using it for their light meter, and it's called multi-jet fusion. It's a proprietary process of Hewlett-Packard. They have these really fancy, big, expensive machines. The downside is it really can only print in black or some kind of a gray color, but that one is completely opaque. But what makes 3D printing kind of a challenge on the commercial side is that I'm not running the machine. Um, so I can't control tolerances. And if you look at a lot of the big companies that do commercial 3D printing, they have these big spec pages of, you know, we can do plus or minus this amount or plus or minus this percent. These are the tolerances we're allowed to get away with. And they're really not very good. And so the challenge was, if the person running the machine doesn't care about me and my needs, multi-jet fusion's horrible. But if they do, it actually can work pretty well. Whereas SLS actually works fine in either case. So yeah, I was going crazy with this last year, but it's all sorted out. I found a place that could do multi-jet fusion repeatably with good tolerances, and that's what I'm going to be going with. Now, this order took a while because they were kind of backlogged at the tail end of the summer. In fact, I think they even wound up outsourcing some of this order to HP themselves. So if I'm lucky, that might actually mean I get a better result, I hope. But the only catch is apparently HP's dyeing equipment wasn't dyeing the material quite as dark. So the production devices might not be quite as black as some of the pre-production ones. Functionally, this shouldn't make any difference. So, I hope everyone can hear my rambling okay. I'm going to switch over cameras and we'll start unpacking. Okay. I still think it's kind of weird how you can see one camera and the other. Okay. There. Okay. Hopefully I'm coming through okay from the webcam, even though my back's to it. This is the big box. Let's see how this goes. Okay. I just love packing paper. Yeah. Okay. Yes, so here we go. Bags of parts. They still look pretty good. So the printalizer densitometer assembly is made up of 4 pieces. There's the top, the main body, the top, the lower body, and the bottom cover. So this looks like the main body. Another bin of those. Oh, another bag of those. Yeah, this is the top piece. I affixed a graphic overlay to this to make the top of the device that you actually see. More of those. These are the bottom piece of the device. Plenty of those. And the base. I think I'm going to take out a complete assembly's worth quantity 1, just so we can look through the parts and see how it goes. So, there's no way of like serial numbering these prints, so I'm not even going to bother. So we'll just take out 1 from each box, each bag, and I'll just set them up on the table. Of course, these are probably famous last words, but this does incorporate like 1 or 2 very last-minute tweaks on top of the pre-production devices. I don't remember what all of them are. I really hope I don't regret that. But yeah, okay. So, let's go over to the table. Yeah, webcam view is solid. I guess you can mostly see my butt through that at this point. I should probably shut it off. But, okay. So, so maybe I can switch over to video camera audio. Yeah. There we go. Video camera built-in audio. Let me drop the volume in that a little bit. Okay. So, over here, these are all the parts that make up the unit. One last-minute change that I made. If you maybe can't see in here, this is where these rings go around. I added a little inner groove in here. So when I was putting these together, the problem is the inside edge of this depression kind of had like a little bit of a bevel just from the material process. And I was having trouble getting these things to actually fit all the way. So what I wound up having to do is come up with some sort of a way of sticking this on the end of a drill, spinning it around real fast with a file, and rounding the edge just to make it fit. And I didn't want to have to do that, so I added this little inner groove here, which looks good, that should hopefully avoid that problem. And we'll know for sure once I start to actually glue these together. Okay, and then so I also made these little pieces, the bottoms of some of the springs come through here. I made these a little longer and added a little pocket so I can blob some silicone in there just to help holding the bottom of the springs in. It's another last minute change I made. So, let's see. So that goes together like that. Top goes together like that. Now, when I was going back and forth, driving myself crazy about manufacturing for this, so some places would say something like, We're okay if it's plus or minus 0.3 millimeters. We're not going to care about your problem if that's the case. Well, you know, you do that in one direction on one part, another direction on the other part, and all of a sudden these pieces that are supposed to mate together overhang and none of the screw holes line up. So that's important. So this fits together pretty well. I actually made a bunch of weird design kinks in here, or these little features here and around here, so that this thing would rest down and kind of lock so that when it was closed it wouldn't have any side-to-side play. Very important if you want repeatable transmission measurements. So, big thing we need to find out now is do all the parts fit? That's one thing that's worrying me a little bit. So one thing that's always a challenge with these is getting all the tolerances on everything perfect. You have all these little screw holes, all these little bits and pieces, and you know, everything has to go in just perfect, and you wind up iterating over and over again. Oh yeah, here's another thing that I did. So I slightly thickened the amount of plastic between here and the inside of that pocket so I could use slightly longer screws. I discovered the screws I was originally using were too short. In the final pre-production devices, I used some washers to make up for that plastic being a little thinner. The final ones, I shouldn't need it. But yeah, so mostly what I'm worried about, let me zoom in, is, and I won't really know for sure till I start doing some assembly, is whether these screw holes right here are actually big enough or not. If they're not, they're still probably big enough to tap. If I have to tap them, I can. I just hope I don't. The rest all look good. So yeah, if you want to know why 3D printing is such a benefit to a device like this, well, it's first of all we have the whole hinge, but also the sensor cone right here. This isn't just a cone of plastic. It actually has these 4 channels on the side that come up to where the different LEDs are, and they shine down at a 45-degree angle to hit the bottom target, and that's much easier to do with 3D printing. And then in the middle, we have a stack with a diffuser and a UV-IR filter, and then the circuit board goes on top. So, yeah, aside from a minor concern over those holes, which I can work around if it is an issue, and it may not even be an issue, this actually looks pretty good. Of course, the one thing I'm always a bit nitpicky about is whether these will fit properly in here. They do around the edges. They might need to be pushed down a little bit. I'm a bit hesitant to push something in just because it may be hard to get it out. But I could actually try gluing one in. So let me go get one of the final rings. Okay, let me zoom out a little bit. Okay. Let's little jigs. In fact, I even made a jig specifically for this. Anytime I need to hold one of these devices in a specific orientation, I make a jig. So we've got this jig right here that's designed for this to sit on top, so I can bang on it and not have to worry. So, got a few things we got to do to put this together. Obviously, when I'm doing this for real, it's going to be done, you know, in quantity, in bulk. I'll have a whole bunch lined up, but yeah, we're just going to do one right now just to see how it fits. Okay. So first we're going to do this outer ring, which is relatively easy. So this plastic here has two sides. One's completely matte, one's shiny. The idea is the matte side is up so we don't track our fingerprints. So this is going to be shiny side down. So to put the outer ring in, we just dab a little ring of super glue around there. Take this, put it over, and then press it. Okay, that is not good. Run into this problem before. What the heck? Okay, that inner part is too big. Yeah. This is going to be a problem. It actually makes me wonder if the middle piece will actually fit too. Okay, I'm not going to glue this one in just yet, but I will try to see if it goes in. Yeah, it actually does. Oh, it friction fits too. The original plan is actually to squirt a little bit of super glue around the bottom of this thing to seat it. But this seems to be held entirely by friction. May not even need glue. The problem is this outer piece is just not fitting at all. And it's hard to tell whether it's the outside or the inside. I am going to go get the calipers. Okay, so what are we dealing with here? Yeah, so Jonathan says, interesting insight into the design and build process. Yep, and you're even seeing the ugly parts that I don't always share. So let's see. This ring is supposed to be, I guess, either 30 or a hair under. That's 29.8 on the outside, 10.05 on the inside. This pocket here is 29.63. Yeah, 29 and a half about. So this is wider on the outside. And the in part here, that's 10.1, 10.2, and the inside of this is 9. Yeah, these dimensions are off. There's no way that's going to go in. So okay, so now what we're going to do is I'm going to bring up the actual CAD models for this thing, which should just take a minute because Fusion 360 likes to make you sign in fresh if you haven't used it in a while. So this will just take a few moments. Now it's going to send a code to my phone. Okay, I'll be switching over to the computer desktop in just a moment. This isn't the computer I normally run the software on, but it's the computer I have in the lab. Ultimately, though, this means two things that I really, well, it means two things that I would rather not be the case right now. It means that at least for the bottom half of the enclosure, I am not going to be able to start production for at least another week or two. The top I should have no problem with, but we'll see. And it also means that I either need to get the bottom half remade with the right tolerance, with the right dimensions, or I'm going to need to have those acrylic discs recut with a slight tweak. The acrylic discs might actually be easier. I just hate the back and forth trial and error. So now Fusion just needs to update. So yeah. Okay. Don't worry, I'll switch over to my desktop in just a minute. Let me switch over to web. Okay, speaking on the webcam now. And we probably won't continue this stream for that much longer. Just want to get through this little bit. Okay, so now we're over to the desktop. So, let me resize this so that it fits nicely. Let's see. Yeah. Shut off the video camera for now. Actually, no, we'll leave it on. We'll leave that on in the corner. Okay, so here's what we're going to do. I've got Fusion 360 up here, which is, this is the CAD model for the device. I sort of have two versions of the model. This is the one that has all the parts in it. I also have one without the parts, but we'll keep this one for now. So we need to figure out is what are the dimensions supposed to be and what actually are they. So we'll take off a few pieces here, and this is really what we're caring about right now, this in right here. So in the base we've got so if we take the outer body out, so this outer ring is supposed to be a diameter of exactly 30 millimeters, and this inner piece is, actually we don't care about the inner piece, that actually worked. So it should be 30 on the outside and 10 on the inside. So if we look at what we have over here, this ring was a hair under 30, about a quarter of a millimeter under 30, due to just probably the kerf width of the process, and almost exactly 10. So that was okay. So now what we really care about is let's take these pieces out and see what the model's supposed to be. So this is supposed to have a diameter of 30.2, but the actual one measures at, and these circles are kind of hard to measure accurately anyways, but 29.46. So yeah, about a third of a millimeter off, which is actually enough for things not to fit. I mean, the goal is for there to be a little bit of slobble out in there. So I mean, the inside of that is 29.46, and the outside of this ring 29.82. Yeah, that's too small. And the inner piece here, the diameter of that is supposed to be 9.45. And what is it actually? 10.26. We got a problem. While we're at it, though, I'm actually curious about those screw holes on the bottom that I spotted. But, you know, that's less of a concern. These are hard to measure accurately anyways. So, but while we're at it, I'm going to want to measure all of these parts eventually. But let's do some basic other measurements just to see, you know, how things come along. So let's see if I can, yeah, collapse this a little bit, make this a little there. So yeah, Now let's just check the other major dimensions of this part. So we want to know is how wide is it supposed to be. So from there to there, that should be exactly 48 millimeters. What is it really? Uh, 48 and a quarter. Okay. Um, that one being bigger isn't really a problem. And then this way is 113.13. This one is a little harder to measure. Let's see if we can. No, it's always annoying. There. That says, if I probably didn't, if we do XY, yeah, 113. So it's a hair over in that dimension. But let me go get an existing unit, not a disassembled one though, and we'll see how it compares. Okay, so this unit is from the pre-production batch, and we're going to see how its measurements compare. So this one was measuring, so let me switch back. Okay, so the width, so it's supposed to be 113 long and 48 wide. So what are we really? So this one's 48 and a quarter, which is not good, but not terrible for that dimension. And this one is about a tenth of a millimeter less. Not that big of a difference. And this dimension is supposed to be 113. It's almost exactly 113. Well, it depends on how well I line up this. It's kind of hard to measure these things fully assembled. Yeah, it's a little bit longer. That's okay. So, not that big of a difference in those dimensions. But, yeah. So, just curious if this one fits any differently. No, this is an older run of the acrylic pieces. That's the same problem. Okay, so I'm going to need to deal with this. Probably shouldn't waste all your time on camera with it, but one thing we can attempt is to see if the circuit fits. So here we have a thing that I sort of threw together to help with assembly. This jig holds that nice and locked down. and I can stick a circuit board on top and we'll see how well it lines up. So I could measure this. This should fit a 14 by 14 or 15 by 15 square. No, that's supposed to be 15. It's measuring a hair under. That might not be a huge problem. So, okay. So we have a circuit board here. This is what the circuit board for the device looks like. And what we want to find out is, does everything line up, particularly the mounting holes? So we're going to drop it in. Then I'm going to grab a light. And we're going to see. Okay, thank goodness. The holes do appear to line up. This is exactly what we were hoping for. There are no buttons on this one, but that's okay. I haven't soldered them onto this one yet. What's really just important is that all of these holes line up, which means I should be able to put it together. Okay, so I'm not currently planning on complaining about these top pieces, but that bottom piece is a huge problem. Let me take this circuit board out. And one last thing with the bottom piece. Just going to see what happens if I try to put this in. This is what the transmission light circuit board looks like. This particular one isn't the final design, but the hole patterns are identical. And that's probably okay. I'll probably try this with a screwdriver later. But, yeah. Okay, so it's probably going to cut the stream here. So as you see, I now have all the parts, hopefully for the final assembly. But apparently one of the critical dimensions is a little off on the bottom half of the enclosure. That's going to cause a delay. I'm going to probably want to measure many more parts, and I'm either going to have that one piece redone or attempt to make a modified version of that acrylic piece. It's just was so much back and forth getting all those dimensions so perfectly dialed in. It could take some iteration. I think what I'll wind up doing while I'm waiting on that is focus on evaluating the rest of the circuit boards and maybe assembling the top half of the unit, because I don't think there's anything stopping me from doing that, but we'll see. In any case, that's enough for now. I know this might not have been the most interesting of streams. You got to see the ugly side of this project. But hopefully everyone will have a nice day. This might be the last stream I do for the week, and I'll see you later. Bye.